Good day, students. Welcome to Mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 11 to 15 of the January 2016 Geometry Common Core Regents exam. The goal here is to go over some important tips and tricks that will help you be successful on your upcoming Regents exam. If you have any questions, just feel free to include your questions in the comment section below, and we'll be glad to assist you. All right, so question 11 reads, quadrilateral ABCD is graphed on the set of axes below. So we can see the graph of quadrilateral ABCD. Question, when ABCD is rotated 90 degrees in a counterclockwise direction about the origin, its image is quadrilateral A prime, B prime, C prime, D prime. Is distance preserved under this rotation? And which coordinates are correct for the given vertex? So we are answering two questions. First of all, is distance preserved? Secondly, what are the coordinates of the image after the rotational transformation? One thing you want to recall concerning transformations is that a special group of transformations are called isometries, okay? Isometries, as the word indicates, involves a transformation that does not change the sides or angles, any dimensional component of a geometric figure, okay? One isometry is rotation, okay? Rotation and reflection and translations are isometries. So if you rotate an object, it does not change the size. So distance is preserved, okay? Now, in this example here, we have a 90-degree rotation about the 90-degree rotation about the origin. Is that an isometry? The answer is yes, because rotations are isometries. So what does that mean? It means that distance is preserved. So let's look at the options we have. We can eliminate option 1 and 2 because it indicates that distance is not preserved. Okay? Now, now that we've narrowed it down, all we need to focus on is the transformation of coordinates A and B to A prime, B prime, and see which one is the correct one. Okay, so this is a formula for rotation about the origin. If you rotate a coordinate 90 degrees, let's say you're rotating XY, 90 degrees about the origin, what's going to happen is that you end up with negative y, comma x. The coordinate switch and the y becomes the opposite. Okay, so let's look at what we have here. Point A, the vertex A has coordinates, let's see, 1, 2, and then 1, 2, 3, 4, 5, 6. So it has coordinates negative 2, comma 6. 1, 2, negative 2, and then you go up 1, 2, 3, 4, 5, 6. So if you carry out a 90-degree rotation on this coordinate right here, so what are we going to have? So let's carry out the transformation. Actually, let's write down B first so we can just do the transformation of both vertices simultaneously instead of going back and forth. So B is 1, 2, 3, 4, 4, comma 1, 2, 3, 4, comma 3. Okay, so if you rotate the whole figure, this quadrilateral 90 degrees counterclockwise, what's going to happen to A? So if you apply the transformation on coordinate A, negative 2, comma 6, you're going to end up with A prime, which is what you get when you switch the coordinate and you make y opposite. So you end up with negative 6, comma negative 2, using this formula that we indicated here. Okay, switch your coordinates, 6, negative 2, make the y negative, you have negative 6, negative 2. What if you rotate the point B, that vertex, 90 degrees counterclockwise about the origin? So B is 4, 3, what happens? It maps that point, that vertex, to B prime, which is defined by switching the coordinates, 3, 4, and taking the opposite of the new x coordinate. Okay, so let's look at the options we have to see which one is the correct transformation. Let's see. Oh, this is wrong. Both of them were, well, actually, yeah, both of them are the wrong signs. And then option 4, -3, -4 is where B gets mapped into. So the correct answer for this problem is option number 4. All right, let's take a look at question number 12. It says, in the diagram below of circle O, the area of the shaded sector LOM is 2 pi centimeters square. If the length of NL, this entire diameter right here, is 6 centimeters, what is the measure of angle N? Okay, so what we're going to do first, this is what we're looking for, is that we're going to use the area of a sector formula to find this angle right here. Measure of angle MOL, and then we're going to use the central angles theorem to figure out what the measure of this angle here is. Okay, because they subtend the same arc. So how can we find out what the angle is given the area of a sector? We're going to make use of the area of a sector formula. Okay, so formula. There are two formats for the area of a sector. Okay, we can use the Radian formula or the degree formula. Okay, so let's go ahead and take a look at both formulas first before we go over what the correct choice is. So area in Radian format is 1/2 r squared, 1/2 r squared theta. And then in degree format, the area is pi over 360 times the radius square. Okay, so pi, let me put this in theta times, well, we have to multiply by pi. Let me rewrite that. So it's theta over 360 times pi r squared. That's the formula in degree format. So theta over 360 times the whole area of the circle pi r squared. Okay, so this is radians format, and this is degrees format. So the question now is, which of the formulas are we going to use for this problem? So if you look at the options, they're all in degree format, so that automatically tells us that we're going to be using the degree formula to solve the problem, okay? If we use the radian formula, we will have to convert our final answer into degree form. So in order to save time, we can just make use of the correct formula off the bat, okay? So let's go ahead and apply the formula to this situation that we're dealing with right here. So let's write down the formula again. So the formula is A, area equals theta over 360 times pi r squared. All right, let's list what we know and what we need, and then we'll substitute in this equation and solve for the unknown. All right, so the area, we're told, is 2 pi. Okay, theta is the angle, MOL. We do not know what that is. What is the radius? Since NL, the diameter is 6, the radius is going to be 6 over 2, which is 3. Okay, so this one is since the diameter, which is equal to NL, is equal to 6. So remember, the radius is half the diameter. So this is 3, and that's 3. Okay, so it looks like we have everything we need. So we're going to input it into this equation and solve for theta, the central angle. Okay, so we have 2 pi equals theta, which is unknown, over 360 times pi times the radius, which is 3 square. Okay, so we're solving for theta. Now let's simplify the right side. We have 2 pi equals theta over 360. 3 times 3 is 9 times 9 pi. 9 goes into itself once and goes into 360 40 times. So now we have, let's write this equation as 2 pi equals theta over 40 times pi. Okay, now how do we get theta by itself? Well, we can just multiply by the reciprocal, so we can multiply both sides by 40 over pi. Okay, 40 over pi. Why am I doing that? Well, I have 40 down here. If I multiply by 40, that cancels. And I have a pi here. If I divide both sides by pi, that cancels. So we'll look at what happens on the right side. The 40s divide out, and the pi's divide out also. Okay, and on the right side, on the left side, the pi's divide out, and you end up with the value of the central angle theta, which is, remember, this is degree format, 80 degrees. Okay, so now, does that mean our answer is option number 4? Is that our correct answer? The answer is no. Okay, we weren't asked to find the central angle. We were asked to find angle N. We just found out what this is right here. This is 80 degrees. So you need to be careful. Make sure you're answering the question. Don't stop halfway when you see a distractor. Okay, so option number 4 is basically a nice little trap there. So what are we going to use to figure out this angle? We're going to be using the central angle theorem. So we have a reminder here about the central angle theorem, that the central angle is always twice the measure of the inscribed angle as long as they subtend the same arc. So this angle is twice angle N. So what do you double to get 80? You double 40. Okay, so we can, if you want to solve it algebraically, you can just simply say that using the central angle theorem, twice the measure of angle N, twice the inscribed angle is equal to the central angle. So you divide both sides by 2, and that gives you the measure of the inscribed angle, which is 40 degrees. Our answer is option number 3. All right, let's take a look at number 13. It says, in the diagram below, triangle ABC is similar to triangle DEF. If AB is equal to 6 and AC is equal to 8, which statement will justify similarity by SAS? So what does SAS similarity postulate mean? So S is for side, A is for the included angle, and then S is for side. Okay, so SAS basically means that the corresponding sides are in proportion. Corresponding sides are in proportion, and the corresponding angles are what? Corresponding angles are congruent. Okay, so what are the sides we're looking at here? We're given AB and AC. These sides, you have AB. Let's write that again. We have AB. That corresponds to DE. And then BC corresponds to EF. Just following the order of the letters, you can tell which sides are corresponding. So this side corresponds to this side. And then this side right here corresponds to this side. So these are the SS for SAS. To justify similarity, this angle must be congruent to this angle. Okay, so look at the options we have. Which of them has angle A being congruent to angle D? Options, well, C is also congruent to F, so it could be any of these because these are corresponding angles and they're congruent. So by relying on the angles alone, we cannot get the correct answer. So we have to look at the proportionality of the sides. Okay, so AB and DE are corresponding sides, AC and DF are corresponding sides. So their ratios have to be equal. Okay, so we are going to have AB over AC has to be equal to DE over DF. Okay, let's make sure we're giving it, okay, DF. All right, so we don't know what DE and DF are, so we're going to figure out what AB and AC are, and then look at what options, which combinations of DE and DF will give us the ratio that we get when we divide these two sides. Okay, so AB over AC, let's do that first. AB over AC is 6 over 8. Reduced by dividing both sides by the GCF, which is 2. So the ratio is 3 over 4. Okay? So now let's look at, let's test out our options. Option number 1. If we test out option 1, we're looking for DE over DF. Okay? Is DE over DF, is it equal to 3 over 4? That's the question. Okay? So for option 1, DE is 9. If we divided by DF, 12, what do we get? What does this reduce to? Divide this by 3, divide that by 3, and we end up with what? 3 over 4. That is excellent. That is exactly what we want. Our answer is option number 1. Now, what if DE and DF didn't work? DE and DF wouldn't. If that didn't work, then what you do is you go to option 2 and then you carry out the division process again to see if you get 3 over 4. And then just to backtrack to what I stated earlier, we can actually eliminate options 3 and 4 because angle C is not in between these two sides that are provided. So since we're doing SAS, we must look at the angle that's between the sides with the given measures that we're using to establish proportionality. Okay, so 3 and 4 should be eliminated from the options. Answer is option number 1. All right, let's take a look at question 14. It says the diameter of a basketball is approximately 9.5 inches and the diameter of a tennis ball is approximately 2.5 inches. The volume of the basketball is about how many times greater than the volume of the tennis ball? Now, one caution that you want to be aware of is that whenever you're calculating volumes, you want to make sure you're using the radius and not diameter. Okay, sometimes you might not be paying attention, you just rush into the whole process and you just assume that these are the radii and you just plug it into the formula and you get the wrong answer. So make sure you are using the radius. Okay, now let's take a look at the formula first before we start computing and comparing the volumes of the two spheres. Okay, so formula. The balls we're looking at, basketball and tennis ball, are spherical objects. So we're looking at the volume of the sphere. Volume of the sphere is given by 4/3 pi, note r, okay, r cubed. We're using the radius here. And then let's put a side note here, note that the diameter, the radius is equal to the diameter divided by 2. In this problem, we were given with the diameters, okay? So we're going to have these measures to get the complete radii. Volume of the basketball. So the basket. So for the basketball, we know that the diameter is 9.5. That's not what we're going to be using. We need the radius. So all you do is you can use your calculator to divide 9.5 by 2. If you do that with your calculator, the radius is 9.5 divided by 2. You end up with 4.75. Okay, so the volume of the basketball is going to be 4/3 pi times the radius, 4.75 raised to the third power, following this formula that we wrote up here. Okay, so let's plug this into the calculator, see what we get. All right, so we have 4 divided by 3 times pi times 4.75 power 3 raised to the third power. Enter 448.9205. All right, so let's write that down. 448.9205. Now let's go ahead and find the volume of the tennis ball, and then we'll do the comparison of their volumes. So tennis ball, the diameter of the tennis ball is 2.5, what's the unit, inches. So it's 2.5 inches. So that's not what we're using to calculate the volume. We're going to be using the radius, which is half of the diameter, 2.5 over 2. You can divide this with your calculator. You end up with 1.25. And the volume of the tennis ball, we can write it as V sub t is 4/3 pi times 1.25 raised to the third power. Okay, so plug that into your calculator. Let's go ahead and do that. So we're going to do, let me cheat here. I'm just going to call up my previous answer, and I'll change the radius to 1.25. Enter 8.181. So 8.181. So how do the volumes compare? How much bigger is a basketball over the tennis ball? So you're just going to go volume of the basketball divided by volume of the tennis ball to see how much bigger it is. So you're going to compute the quotient of 448.9205 divided by 8.181. Okay, so you plug that into your calculator. So 448.9205,002 divided by my previous answer, 54.872, which is, if you round it up, is approximately 55. So our answer is option 3. Okay, the size of the basketball, the size of the volume of the basketball is almost 55 times greater than the volume of a tennis ball. Okay, so some of you might wonder, why did we divide? Okay, so the reason we divided here is because of the keyword how many times. Okay, if they use the word how much more, greater, then we're going to subtract. Okay, so times is multiplication, and the inverse of multiplication is division. More is addition, and its inverse is subtraction. Okay, so if they say how many times greater, you divide to find that ratio. And if they say how many times more or how much more, then you subtract to find the difference. Okay? All right, let's take a look at number 15, the last problem in this review installment. It says the endpoints of one side of a regular pentagon are -1, 4, and 2, 3. What is the perimeter of the pentagon? So you need to know your formulas here. There are two formulas that we need to know in order to solve this problem. Okay, first one is perimeter of a regular pentagon. So perimeter of a pentagon with, well, we gotta be specific here. It has to be regular. Perimeter of a regular pentagon, with side length S is given by 5s. You just multiply the measure of that one side by 5. Okay, and then the second formula you need to know is your distance formula to help you compute the length of the side. So distance formula D is given by the square root of y2 minus y1 squared plus x2 minus x1 squared. Okay, so that's your distance formula. So what we're going to do now is use the distance formula to find the length of a side, and then use the side length and the perimeter formula to compute the perimeter of the pentagon. Okay, so let me just give you a visual of what I'm about to do. This pentagon I just sketched here is just a rough sketch. It's not drawn to scale, okay? So we have 5 sides, S, 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 S. All those 5 sides are all congruent. Okay, that's what regular means. It means that the measure of each side is the same. All right, so we're given the coordinates of 2 vertices. So let's say this one right here is -1, 4. It's not drawn to scale, so just pardon me. And then this one is 2, 3. So we need to find how far is it from here to here. How long is S? If I can figure out how long S is, I just multiply it by 5, and that will be my final answer. Okay, so the distance formula helps us to compute this length, and then the perimeter formula helps us to find the perimeter. So let's go ahead and find out what S is first. So length of one side S is given by, we're going to use the distance formula. Now let's write down our points. We have -1, 4, and 2, 3. So this is x1, y1, and this is x2, y2. You want to be really careful when you're substituting these values into your formula so you do not make sign errors. Okay, so we're going to have the square root of the sum of the squares. So square root of x, y2 minus y1, 3 minus 4 quantity squared, plus x2 minus x1. You have minus there, like that, and then you square that to complete your radicand. Okay, so evaluating the square roots will help us determine what the side length is. Okay, now if you're using the regular TI-83 calculator like this one, you might run into some complications because our answer is supposed to be exact. So we want to try and do this one by hand. Okay, all right, so let's see what we have here. So we have 3 minus 4 is -1. -1 square plus 2 minus slash and dash is 2 plus 1, which is 3 square. So what happens when you square a negative number? It becomes positive, right? Because minus times minus is plus. So you have 1 plus 9. That is equal to root 10. Okay, so let's look at our options. Is our answer option number 1? Is that our answer? The answer is no. Okay, so you gotta be careful. Make sure you're answering the question. You were asked to find the perimeter. You were not asked to find the measure of the side length. So we are halfway. We just found how long this side is. This is root 10. How do we finish the problem off? We have to use the perimeter formula to finish off the problem, okay? So be really careful about those tricky distractors that deceive you into thinking that the problem is completed, whereas it is not, okay? So the perimeter is 5s. If we substitute s into this formula, we have 5 times root 10. And that, ladies and gentlemen, is your final answer, option number 2. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is valuable to us. Don't forget to subscribe for updates to the remainder of this review series. If you have any questions, just place your questions in the comment section below and we'll be glad to assist you. More clips can be found on Mathgotserved.com. Thanks again for watching and have a wonderful day.